So welcome to a very interesting semester here at Harvey Mudd. We certainly left off in the spring in an interesting situation, and we continue to do that during the semester as well. So I have tried to do my best to make this work as an online course, and my hope is it will do so well. But I do imagine there will be technical challenges along the way. And so, especially at the beginning, so we'll just kind of bear with me as I work through those. Please let me know if you have any problems either hearing or seeing me or seeing my screen. If I'm talking about something that I think should be displayed and it's not being displayed, please let me know. So this is operating systems. We have one more coming on. All right. Well, I'm Neil Rhodes. So I have been an instructor here at Mudd for the last 3 years, and I was also part-time faculty maybe about 6 years ago, something like that. Before that, I taught at UCSD, and in the interim between UCSD and Harvey Mudd, I was an engineer at Google in Irvine. So let's just go ahead and kind of get started. Today is going to be purely a day where we talk about logistics. Okay, we're really not going to get introduced to the topic at all, and I'll explain why in just a moment. So we do have a course website. So the course website's where basically almost everything's at. Our syllabus, calendar, instructions for labs, resources, everything else is there. And that is, oops, this site here. Okay, so this is also referenced from Sakai. So if you want to just keep a link to Sakai, Sakai has a link to everything else. But the course website is where you'll be spending much of your time. We're going to be using Piazza. So this is the Piazza link, but the Piazza link is also available both from the course website and also from Sakai. Let's see. Before we go any farther, can we just go through and can I get a short introduction, just an audio introduction from each of you? So I know you're juniors and seniors, most of you are Mudd students, and just a bit about perhaps how your summer has been and and how this fall is starting out. So let's start with Alejandro.
All right.
And something interesting about yourself. So
okay.
my interesting thing is I was in a circus. So let's talk a little bit now about the structure of the class. So first off, we're going to be running this as what's called an inverted classroom. So lectures are not during lecture time, and homework type stuff is not outside of class. So the lectures are going to be pre-recorded and available basically in a YouTube playlist online. I'll show you an example of that in just a moment. And then we'll talk about what happens in class, but it's basically not those lectures. The calendar on the course website has all the playlists. And part of what we're going to be looking at through the lecture and also through assignments is a traditional operating system called XV6. And we're going to be doing some in-class assignments with that. And that'll be related to the lecture topics we're working on. So let me show you. Just a second. All right, so we have here the course website, and is that showing? Okay, great. So this is the course website. We have the schedule, and this is where everything interesting happens. We have some preparation to do before class. So there'll be pre-class videos and there'll be readings. You are not responsible. There was no pre-class videos, of course, for today because you didn't know enough to do that. There is some reading here, which I've actually misplaced because you couldn't do that reading as well because you didn't have this. So I'll move this over until Wednesday's preparation as well. So you can see here the pre-class videos. And so again, that's just a YouTube playlist. This one is particularly numerous because we've got not only about 7 lecture videos, none of which are that long, except this one that went pretty long at 26 minutes, but it's still under an hour and 15 minutes. But then there are also some tutorials that are going to be really useful. Even if you know Bash or know Vim, or no SSH or GDB, I still recommend you watch the tutorials because I have what I think are some useful tips in there. My guess is you'll probably pick up at least one tip if you're not really good at really good at each of those. Okay, and I realized in the past I have given sort of my tips on some of these things at either the last lecture of class or kind of during lab sessions as I'm just working with people, and it seems to be better to just front load some of that to make you be as productive as you can be, not only in this class, but for the future. Let's just give you an example of what one of these might look like. We've got our emulator. And can you guys hear that? And then on top of that, we have our... Okay, so it's a combination of sort of writing on a board Windows or anything and like that. Also, so the operating system we've got here, slides and things. Our registers that we have to emulate. How can we do that? That was part of my project this summer, was coming up with the facilities to be able to do that. Aaron, welcome. All right, let's look just a bit about at the website. So we have the schedule, which is sort of the main thing. We have here the syllabus, which is going to be important to read, especially as we talk about kind of how the class is running. It's somewhat untraditional. All right. We have labs. So there are a total of 9 labs. We have a couple of introductory pieces, and then we run into, let's say, this lab, which is a bunch of pages of instructions to finally do this lab. And when you're at the very end, you actually submit it. These labs are going to be worked on throughout the semester, and they're going to be worked on either individually or in groups of 2. My recommendation, my strong recommendation, is that you work in pairs. But if you are really, it's important to you to work alone, you can do that. By the way, if there are any questions, feel free to just turn on your audio and ask the questions. Otherwise, I'll try and keep an eye when people have their hands up, but I may not be as good at that as I would like to be. All right. So that's the labs. We have then a lot of reference material on a fair amount of things. We have a link to the Piazza. We have XP6. I'm going to talk a little bit about that separately. Okay. So let me go back to our slides. All right, so in class, so before class, what you need to do is watch the lectures, read the assigned readings. So that's my expectation when you come to class. And then in class, we're going to be doing, often we'll be doing programming assignments. So these are not labs, which are much longer, meatier sort of projects. These are going to be shorter assignments, and they're going to be based on XV6, usually, which is a particular operating system. So I'll talk about that in a moment. We also will work on these in groups, and these are going to be ad hoc groups. Okay, that is, I'll just randomly break you up into breakout rooms, and you guys will work on this. So what that means is you guys are going to need to bring a computer that allows you to SSH into Knuth, right? And then you, in the breakout room, will share one person's connection to Knuth, and then go ahead and do whatever the exercise is. Not all the exercises are going to be program assignments. Some will be other type in-class experiences, okay, in-class exercises. And then we'll also have questions in general that have come up from the lectures or the reading. Probably if you have questions, the first place to put those questions would be on Piazza. And the reason for that is to go ahead and address those questions before lecture time, right? Other people may have those questions as they are watching the lectures or doing the reading. And so it would be nice to be able to get answers to those before class. But I think we'll start out most classes with any questions that people have and go over those. Does that make sense? Are there any questions right now? Okay. So the in-class program assignments, many are going to be using XV6. So let's talk about what XV6 is. It is an x86 operating system. It's small. Okay, it's written in C. And it is modeled after Unix v6. All right, so Unix v6 was one of the first versions of Unix that was actually available outside of Bell Labs. And it was also a it was also a version of the operating system where a guy in Australia went ahead and created a book based on the operating system. So what he did is took the operating system and then went ahead and created a commentary on it, referring to things line by line, okay? So that you could actually look and see for a real operating system, how are things implemented and what's happening here, what's happening here, what's happening here, and so on. Okay, so we provided kind of a story about the operating system when it was used to teach operating systems. Unfortunately, what happened is AT&T kind of realized that they didn't want their source code out there, and so eventually caused the book to sort of be shut down. It turns out that these copies of the book were sort of passed around from person to person, Xeroxed, the old sort of Soviet Union samizdat style for this forbidden information that was passed around. And so that was passed around, you know, multiple generations of photocopying. And so that part of the reason that was done is because it was very instructional, right? It really explained exactly how things worked. XV6 was designed in the same way. So XV6 was designed from the ground up as well, but intended to be small and approachable and with a commentary. So let me go ahead and show you some of that commentary. All right, so if I look at XV6, so there's just kind of an introduction about it, where to get the source code for the operating system and for the book itself. And then what we've got is a printout for the book. So let me make this a little bigger so you can see it. So this is a printout, and it has an index, which is kind of handy. Let me just get to some source code. So here's some source code. So here's a header file, xv6 memlayout.h. And we can see this is the code. And we have line numbers, right? So every page starts on a even 50. So this page, this memlayout.h starts at 200, depth.h starts at 250, and so on. And so we have unique line numbers for everything. And in fact, if we go to the end of this, we can get an idea of how many lines of code there are. And we can see there are right around 10,000 lines of code. Okay? So what happens is that the commentary then can discuss particular line numbers and uniquely identify a piece of code. So that way you don't have to kind of say, well, in the run command function, the part where there's a switch statement. Instead, it can say, line 8618. And now let me also look at the book. So the book has basically a bunch of chapters, all right? And if we look at one, so for instance, this is interfaces for an operating system, talks a bit kind of about what an operating system is, gives some overview. I know you can't read it, I'm just running through it. Right now, it's not talking at all about particular lines of code in the operating system. But let's look at where we get to some of that. So that'll be probably after our overview. Well, here's an example where we look at this. So here, a PC powers on, Appendix B explains the details, and the bootloader starts executing at entry, which is line 1044. Okay, so now you can run over to 1044 in the book and look at that. We can see now maps virtual addresses. There's a constant at line 207. Entry page table defined at this line. So you can see you really want to work back and forth with the printout of the code and the XV6 book. So part of your preliminary readings, preliminary work for class time is going to be reading parts of this book. And as well, we're going to be doing some programming with it in our in-class exercises. However, the labs, those 9 labs, are not XV6. Okay? So 9 labs are not equal XV6. They're going to be using a different operating system. We'll talk about that in a moment. And by the way, the name XV6 is because it's like V6 for x86. So it's a conglomeration of those two is where we get XV6. All right, let's go back to our slides. And again, yes, XV6 is V6 plus x86, or V6 for x86. So we've got 2 different operating systems. We got XV6 and we got JOS. XV6 we've talked about, modeled after a Unix v6, so it's kind of a traditional style kernel. It's small. It's definitely not as complicated as modern Linux. Let me just show you this. Let me read this to you because it's probably a little small to read. So this is, it's a little small for me to read too. Where did my glasses go? Well, I'll just get close to see it. So this is 25th of August, 91 from Linus Benedict Torvalds. Hello, everybody, and they're using Minix. I'm doing a free operating system, just a hobby. Won't be big and professional like GNU for 386 AT clones. This has been brewing since April, so this is already August, and is starting to get ready. I'd like any feedback on things people like, dislike in Minix, as my OS resembles it somewhat. I'm currently ported Bash and GCC, and things seem to work. This implies I'll get something practical within a few months, and I'd like to know what features most people would want, Any suggestions are welcome, but I won't promise I'll implement them. And at the end, he says, P.S. Yes, it's free of any Minix code and has a multi-threaded file system. It's not portable, uses 386 task switching, and it's probably never will support anything other than AT hard disks, as that's all I have. So it's just interesting to see how a small operating system like Linux, well, like this free operating system that doesn't have a name, which eventually became Linux, can actually grow a fair amount bigger. So actually did, of course, become portable to more than x86, did support more than AT hard drives, and actually has come quite a long ways. So modern Linux is much, much, much bigger than JOS or x86. XV6 is around 10K lines of code. JOS, I believe, well, so it sort of depends. As you start out, I think it's around 6K lines of code. We're going to see that in just a moment. But I'll try to be very clear to distinguish XV6 and JOS as we're talking about it. When we're talking about how an operating system works or how these operating systems work, they do have different behaviors and are implemented differently. And their interface that they provide to user programs is different. XV6 provides sort of a traditional Unix interface. JOS provides a different interface, kind of a lower level interface in what's called an exokernel style. But as we work in JOS, we have these 9 programming labs, and what happens is each programming lab builds upon the next programming lab. So we'll start with something very simple and add some code to it, and then once you add the code and get it to a certain point, we will go ahead and provide you often some extra code. So let's say you finish lab 1. As you move into lab 2, we'll provide you some extra code to go into lab 2. So you'll be taking the output of, let's kind of look at this. So we have lab 1 start here, and then your work here. And then this will take you to lab 1 end. Lab 1 end will get combined with our lab 2 start to give your start. You'll work, and you'll get a lab 2 end. This is all going to be handled with Git, basically. So basically what you're going to be doing is creating a branch from lab 1 end to lab 2 start, merging in our lab 2, and going from there. And is it Zinton? Is that right?
Yeah, sorry I'm late.
Okay. Nah, that's fine. I will have this recorded, and I'll post a recording so you can see it. Or if you want, you can also join in on the first part of the section 2 if you want.
Yeah, sorry, I messed up the times. I thought it was 1.
Yeah, no worries. I know originally this was a 1:15 to 2:30 class before they changed all the times. So just make sure you check all the rest of your classes.
Thank you.
All right. And that's true, actually. So I will post a recording of today's video, and we'll likely do that for all class sessions. All right. So which is better? Raise a finger. Is it better to work solo or work in pairs for the labs? And 2 is right. 2 heads are better than 1. Okay? The labs are not easy. You will learn a lot, I guarantee you. And it's where, right? So you can learn a lot in theory, right? But until you actually put it into practice, you don't really learn it, because you have to know it completely in order to be able to implement it. So there'll be a lot of learning there. I will try to help you as much as I can. We do have 2-hour lab sessions every Wednesday night where we're just dedicated to working on those labs and me helping you out. But just keep in mind, it's it's challenging, and it's a fair amount of work. Okay, so highly recommend work with someone else. You need not pair program in the traditional SIDS. That is, you don't have to have every line of code written with both of you there. However, having said that, there's a lot to be said for doing the pair programming. And you are both responsible for all the pieces of code that are written. So part of what's going to happen for a lab is when you submit it, we're going to have your group and I, the two of you and I, will have a office hour. Well, 15 minutes in an office hour, and we'll talk, and I'll ask you questions, and I'll make sure that both of you understand it. Okay? So, so you're sort of jointly and severally liable for all of the code, all of the changes that you've made.
Forgive me if I missed it, but when we're doing the labs, if I'm working with a partner, do we submit one code, one lab per pair, or is it?
I didn't mention that, and yes, you're going to be submitting one work product per pair. Yeah, so one Git branch is going to be submitted for the both of you, and then both of you will come together to office hours to talk about it, and then I'll talk a little more about this as we go. Okay, so JOS, you're going to be building this up. You're going to be using GCC, and you're going to be using QEMU. So QEMU is, so JOS runs on x86, as does XV6 runs on x86. So they run on bare machines. They boot up. So therefore, instead of having to have a bare machine to run on, we're going to be using a virtual machine QEMU, right? So QEMU is this emulator that runs on top of, in our case, Linux, and that allows us then to boot an operating system on top of that. So that's how we're going to be running both XV6 and JOS. And that's good because we can easily do debugging, and it's good because we don't have to try and, load code into a ROM or EEPROM or something like that to get it to load up. Just much nicer. Let's go ahead and look at JOS, and then we'll come back and talk some more after that. So let's see. Okay. Where's my terminal window? My terminal window is here. All right, so we see my terminal window. Let me make it a little bigger. So I'm on Knuth, and I have, let's just look at XV6. Let me make clean and then make. So we can see we have a kernel. It looks like it's maybe around 200K according to this last line here. Let me go ahead actually and run it. So unfortunately, it makes clean, so it makes it again. But that's okay because it doesn't take very long. And so what happens is, notice it's got 2 CPUs it's running, so it actually does support multiple CPUs. And it's running. It's got a $sign. I've got a shell. What can I do here? I can do ls, and very slowly, show me what's here. Can I do cat? Well, there's a cat right there. Yes, so I can cat. So what more do I need, right? Cat, I can make dir, I could do a couple things, okay? So it is a real operating system. Can I exit? No, it's just trying to run a program called exit, but I can Can I control D? Yes, and it just restarts. So the way I get out of QEMU is I do a control A and X, and that gets me out. You'll learn about that. Okay. Let me just look. So the .h files, the assembly files, and the C files end up to about 11K. So a relatively small program. Let's go up and look at JOS. This is the beginning version of JOS, so what you get as you're about to start Lab 1. So there is other code that would be provided to you along the way. That's not here now. So this is kind of the minimal amount, and this is not a very functional kernel, but nevertheless. So let's also, we have the makefile still has the same target we can run, QEMU Nox, and we can see, so it gives you a hint, which is kind of nice. Use Control AX to exit QEMU, and type help for a list of commands. So I have a plethora of commands. I can type help, but I know what that's going to do, and I can type kern info and get that information. And that's really all it'll do right now. So we're going to have to add a lot more functionality to it. Let's see, CHS, let's look at, again, how big this is. So I said 6,000 lines of code. It's actually only 4,000 lines of code. Okay, so there's really not much there. But the good news is it comes up and already, for instance, has boot code, so that it will boot. That is hard code to get right to begin with. All right, let's go back to the slides. All right, so our lab times, Wednesday, 6 to 8 on Zoom. The way we're going to work that is the first lab this Wednesday may start out slightly differently, but from then on, what will happen is we'll just run those labs as breakout rooms. So that is, every team will be in its own breakout room. And note, actually, the lab times, we're going to combine together both Section 1, which you're in, and Section 2, which is later this afternoon. So we'll have about twice this many people. If you want to have your lab partner to be from Section 2, that's fine. They don't need to be in the same section, because the time we're going to be working on is during that lab time. Do not expect that you can finish the lab during those 2 hours. That is not my expectation at all. That's just a focused time for you to be there, guaranteed that you'll be there, that your partner's available, and also that I'm available. And I'll just be wandering around from breakout room to breakout room. I've never done this virtually, right? But when we did this in person, the way this was done is, of course, we were all in a big lab. People would raise their hand. I would just sort of walk around from person to person, keep track of who'd raised their hand. And if no one had their hand raised, I would go and sit and, look over their shoulder and see what they were doing, maybe ask a helpful question, a Socratic question, or point out something that might be stuck on. And so now what we're going to be doing is breakout rooms. You and your partner will be in a breakout room. You can virtually raise your hand. I'll go through and visit breakout rooms. And again, I'll just drop into breakout rooms as I feel like it to look over your shoulder. My goal in looking over your shoulder is not to make you anxious or nervous, but to see what you're doing so that I can provide some help. Okay? And sometimes it's not going to be help about operating systems. It may be, hey, why don't you use this vim command? That'll make your life easier, something like that. So I'm just here to make your life better. All right, learning objectives. I have broken this class, what I want you to learn, into a bunch of learning objectives. There are 21 bundles of learning objectives. This is one such bundle about processes and threads. So it shows what I expect you to be able to do by the end of the class, the objective. Okay. This is part of how this class is non-traditional. So for the grading, we do assessments. The grading is based on two things, on labs and on these learning objective bundles. So for the labs are pass or not yet passed. There's no partial credit on labs. There's either it's finished or it's not. That's probably a lot like you're accustomed to when you were, for those of you who are interning, for example. If you had code that you needed to submit, it wasn't 90% there. It was 100% there before it was submitted. So some of the things that'll happen, there's a automated grading. In fact, let me just show you that running back to JOS. So JOS is showing, I'll do a make grade. This is before any code has been added to Lab 1. And so we've got a score of 0 out of 50. Okay, and it shows which things are failing. Backtrace symbols is failing, backtrace lines is failing, and so on. Every one of the 9 labs has an automated grading that runs. And your goal, your requirement is to get this to a full score. Once you get it to a full score, then you will go ahead and submit it for a code review. Okay? Again, probably like many of you who are interning or have done internships in the past or done open source work, this is very common. You don't just submit the code, you get a code review from someone else. So this is like life is in industry. So you will submit it for a code review. I will look through it. Most of the correctness is already there because of the automated tests, but it's possible that there may be something I notice that allowed it to pass the tests, but still is not correct that I will note. Other things I'll be looking for are like comments. Let me give you a good example. Commented out code, okay? You shouldn't be submitting commented out code. We have source code control, we have Git, so that you can always go back and get old code if you need to from the repository. So you will want to make sure you don't leave in any commented out code. You want to make sure your comments are accurate. If there's some, for instance, when you start Lab 1, there's going to be a comment that says, your Lab 1 code here. Well, guess what? When you're submitting your Lab 1 solution, should you have in a comment that says, your Lab 1 code here? No. So that's going to be something that I'm going to be pointing out. Even picky things like indentation, right? So if your indentation is using spaces and JOS is using tabs, and I am sorry to tell you that JOS and XV6 are different. I don't remember which one uses which, but one of them uses tabs and one of them uses spaces. And I apologize for that, but that is how it is. You have to match the one you're working in, which is just like, again, the way it'll work in industry. You have to match surrounding code. David, you had a question?
Are we allowed to use like any form of linters or anything for formatting help, or do we have to do that all manually?
I don't care how it's done.
Okay.
What you cannot do is go change the surrounding code, right? Mm-hmm. You can't change the existing code. So this is like the nightmare of moving into, let's say, a small company that doesn't have style guidelines. You get a piece of code, you get a big file and you're making a change to a small function in it, and you reformat the entire file to suit your preferred formatting. And then the next person comes along and they do it for their formatting. And that's why companies come up with style guidelines. It's not that one is right or wrong. It's just we have a decision and this is how we do things. So the decision for JOS is the way the surrounding code looks. If they put a space after an if before a paren, you should put a space after an if before a paren. If they have curly braces on a separate line, you should have curly braces on a separate line. If they do tab it, you do tab it, and so on. Okay, so you want it to match, you want it to look natural. Okay, so that's part of what the code review is going to be. The good news is most of the code review is probably not going to be correctness because of these automated tests. It's going to be more about stylistic sort of things. So this code review will happen. I will we'll go back and forth on that using GitHub, and when it's complete, I'll give you an approved, and then you're good to go. Okay. You're almost good to go. The last thing we'll have is we'll have a oral interview. And that's, when I say last, that's not really quite true. That'll happen in parallel, let's say, with the code review. In some cases, I may waive the oral interview. So it may be during lab time that I've met with you guys enough and have talked with you enough that I know that you both understand it. Okay, but unless I waive it, that is a requirement, and you'll have to make an appointment for a office hour time slot to go over that. Once that's done, the lab is complete, and you're done with it. You got 100% on that lab, and conceptually, you can now go start on the next lab. Practically, you will overlap finishing this step with, so let's see if I can do this. So we will have this, let's say this is lab 1. You'll work and you'll submit for review. Okay, so this is time here. When you submit from review, at this point, you'll now start work on lab 2. Okay? You can't submit lab 2 until lab 1 is completely approved, though. And there may be changes that come about from the code review, right, in lab 1. As we go back and forth, there may be some changes. You will need to go ahead at some point and integrate those changes into lab 2, because I don't want to come into lab 2 and then see the same things I already, we already saw from lab 1. So does that kind of, we'll have much more complete information on this as we go, but that's the general idea. Any questions at this point? Okay. So the learning objectives then, those bundles, how do I assess those learning objectives? There's basically going to be a quiz on Sakai for every learning objective bundle. There are 21 learning objective bundles. And what happens is if you get 100% on that, you have passed that learning objective bundle. So you have shown that you've passed all those learning objectives. If you don't, you retake it until you can. The retake can happen in the following week, any of the following weeks. So as an example, let's say in week 2, you try doing the learning objective on GDP, because we do have one learning objective on that. And, you miss, one of the, I don't know how many questions. So next week, you can sign up to take GDP again. If you pass it, that's great. You could sign up to take GDP and several other learning objectives. Once you finish a learning objective, you're done with it. You never have to go back to it. Otherwise, you may have a set of them that are still open that you haven't passed that you need to complete. The assessments are available only after we've actually covered the material in lecture. So the GDP assessments, there's no assessments available yet, for example. There will be assessments that will be available starting on Thursday, and there'll be more coming out every succeeding Thursday. Until, let's say, the last week of class, there'll be probably a single assessment that's available. Okay. So you would have, I don't know what the number is, something like 12 different tries at the first few learning objectives. And the last learning objectives, you'd have just a couple tries because you'll sort of run out of time. The final exam time period is a time where you can retake any of the learning objectives assessments that you want. That gets us to actual grades. So the grades are based on really only 3 things. How many labs did you complete? In labs, there are challenge exercises. And so how many of those challenge exercises did you do and successfully complete? And then how many learning objective bundles did you complete? Let me just show you in the syllabus the table that describes kind of what you would need to do to get certain grades. So let's see, we're here. So the syllabus, let's just run through this a bit. It's again, it's kind of a description of what we've gone over here. We have the learning objectives. Let me just give you a quick look at the learning objectives. Here are all the bundles. Some of them smaller, let's say for virtual memory, it's just 3 different learning objectives in the bundles, some larger. I did not actually mention yet that the XV6 programming assignments in class go through about halfway through the class. And after about halfway through the class, we'll be working then on papers. So we'll be looking at some different papers in different areas of operating systems, and these learning objectives are about those papers. Okay, so coming back to, whoops. Coming back to, let's see, the learning objectives, this describes more clearly what I just talked about taking, retaking, and so on, and the fact that the 3 hours are reserved for the final, or for that final assessment opportunity. So if you've already passed the learning objective bundles, there's no final, don't do anything. Feel free to ask in Piazza about the assessments, any problems you're having, or in office hours, and so on. Let's see, we were getting to the grading, I'm sorry. This goes over again for the labs in somewhat more detail about the submittal, the code review process, and then the final acceptance. And then the grading, here it basically is. So if you finish all 9 labs, you finish at least 8 challenge problems, and you finish at least 20 of the learning objective assessments, that is 20 of 21. So you've got virtually everything in the class that I wanted you to learn, you've learned, that's an A. And it just kind of works its way down. Okay? So questions on that, because that's probably somewhat unconventional. All right, feel free to ask questions on Piazza about this or any other topic, or ask me in office hours. Let's see, there's one other thing I wanted to talk about, which is office hours. And that is, I have a lot of office hours. The way I am actually working it is, so all these ones that say office here for office hours. So there's office hours on Tuesday, there's office hours on, so there are more next week, let me see. Yes, so we normally also will have office hours on Mondays, Monday nights. So there's office hours on Mondays, on Tuesdays, and on Fridays at this point. So you just sign up for a slot. You click on here, you save it, and that's that gives you a 15-minute slot. Okay, and that way I can kind of know, if no one signed up for office hours, then I don't have to bother actually going on Zoom and sort of just sitting there waiting in case someone comes. If you're, let's say, in a 12 o'clock office hour and no one signed up for 12:15, you can certainly just kind of stay on through until you get all your questions answered. So I highly encourage you to utilize office hours. If you, and the office hours, again, you will also will make an appointment for an office hour to go over the lab that you've submitted. So if there are no office hours, or so they're all taken, or all the ones that you might possibly be able to attend are taken, just feel free to contact me and I will add some more office hours for a particular week. Okay. That covers everything here, I believe. The one thing that I need to add that is not there yet is, so I need to add a suggested lab pace. For when it is, I suggest, if you want to be on track to finishing all 9, that you should be submitting for code review each of your labs. And so I will do that. Just as a hint for lab 1, you should be submitting that by, certainly by mid-next week, so that you're starting on lab 2 next Wednesday night. So we will start on lab 1 during lab times at 6 to 8 p.m. on Wednesday, but you should make time with your partner to finish that off, let's say over the weekend. And that's a much easier lab than the others. So that's certainly, I think, a doable problem. So I will add a suggested lab pace, which I don't have right here. And I do also have a concern. So you are in complete control over when you submit things, okay? Except for the fact that for the learning objectives, that you can only take them once a week, okay? So you can't redo a learning objective and take it 5 times in a day. You can only take it once a week. So in that sense, time limits you. But theoretically, I guess you could wait until the last week of class, or I guess wait until the final, but that'd be crazy. So the last week of class and take all of the learning objectives, all 21 of them, and you pass them all and you're good to go. Or you pass 10 of them and you come to the final and you pass another 10 and then that's fine, you're good to go. But I, for some crazy reason, don't recommend that. You know, I recommend you start taking them right away as soon as you can. And that way you can keep the number you might have open to a manageable number and just be knocking them off, okay? And labs as well, there's the potential for getting behind. So this is a suggested lab pace for finishing all of them. You can go slower if you want to finish less. Similarly for the labs, in some sense, there's no time limit, right? So I don't say you have to finish lab 1 by next week. I just highly encourage you finish lab 1 by next week. But this code review process takes some time, and you can't submit your next one until you finish the previous code review. So I will respond to your request for a code review within 48 hours. But it's not like I'm just waiting there for, you know, anything you might be submitting or any changes to the code review, and I'm going to just hop on it, you know, in the next half hour. So that may take some time. And if we have a back and forth on the code review, that's going to just kind of extend that time. So hopefully after the first couple of code reviews, you're going to learn what I'm looking for, and you're going to just make sure that that's all taken care of before you submit it, so that when the code review comes to me, it's clean, or maybe I have one suggestion, and then you can submit, I'll approve it, and you can go on to the next. Questions about this? So I'll give you a story of when I was, I guess I was a freshman. Yeah, I was a freshman or sophomore. I guess I was a freshman in college. And I had a quarter where I had 2 or 3 self-paced classes. And I remember one of the classes, which was a programming class. In order to get an A, you had to finish, you know, half of the units by about halfway through the course, and then the remainder of the units by, we were on quarters, so I think it was 10th week, so you couldn't go through final time. And I waited until the beginning of the 6th week to start those units. I just hadn't done anything, and that was extremely challenging and a big mistake. So one thing, by the way, about your teams is you are not required to stick with a team. If a team is not working, you can break up. So don't feel you're going to be just stuck with a partnership that's not working. I can't guarantee I can find you another individual to merge together in a team, but at the worst case, you could always separate and work individually. And if you find some other individual to work with, that's fine. Okay, we don't have a sort of process for doing that. That's going to just be as we go. Okay, one thing I'd like to do right now is spend a few minutes breaking up into a breakout room, just so you guys can. We'll break into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll break into 3 breakout rooms, so there are 4 of you in each, just so you can have a quick chat among yourselves because you will want to get partnerships together by, my goal is partnerships by 5 p.m. on Wednesday. When do you need to have your lab partners?
Wednesday.
Wednesday at 5.
5 p.m. Exactly. So by hook or by crook, by piazza, by your large amounts of socializing you just got to do to figure out whether someone is interesting to work with, time in class on Tuesday, looking to see who else is in the section 2 or whatever, get me those assignments if you would please. I think you're really going to enjoy this class. It's a lot of work, but it's also demystifies a whole area of computer science that in many ways is just magic, right? That you don't know exactly how it works, you just know it works, and it just demystifies that. I love it. I think you'll like it too. And I will see you guys on Wednesday. Thanks.
Thank you.
Thank you. See you.
Thank you.
Bye-bye.